would like to do this grand finale a little bit more slowly. So let me start with, often in physics we end up with a vector equation. So we say that we end up with saying that two vectors are equal. Now I'll give you a most important example presently. But what it means is, when we have a vector like this, typically we break it down or we resolve it into axi plus ayj, and with all the previous classes we've been discussing how to do it. So we can find this fx and we can find this fy, and I don't mind telling you one more time that fx happens to be the length of f. In our example it was 5 into cos theta, and fy happens to be the length of y into sine theta. And therefore a can be broken up, and you can also break up b in similar fashion, bxi plus byj. Remember that this whole thing together is a vector. This whole thing together is a vector. This ax is a scalar, this ay is a scalar, bx is a scalar, by is a scalar. I and j are unit vectors in the x and y direction. Now the grand final result is that if these two vectors are equal, then for sure ax, the scalar ax, has to be equal to bx, the scalar ay has to be equal to by. Now another way of saying it is, if these two vectors are equal, they can only be equal if they are parallel to each other, that is, they're in the same direction and have the same length. Now they will have the same, and what that would imply is the x components are equal and the y components are equal. That will ensure that the length of the vectors are equal and also the directions are equal. So this is our result. Now if you apply our result to our most famous problem, Newton's laws says that a vector f is equal to mass into a vector a. Now the step is, you can resolve f into two components, and you can in fact resolve any vector you like into two components, and if you do the same thing here to a, you will end up with mxi plus mayj, and max is a scalar, may is a scalar, fy is a scalar, fx is a scalar, and if these two vectors are equal,